Hello and welcome to Chapter 11, Section 3. Here we're going to talk about exponential growth and decay. So we're going to start with this equation where a is larger than 0. And y is our final amount, a is our original amount, r is the rate of growth, and a rate is usually said in a percentage. It's got a 3% growth, but you have to make it a decimal. And then t is time. So what does that mean? Let's say we're talking about a painting, and our painting right now costs $14,000, but we know that it increases in value by about 9% each year. What is this painting going to be worth in 25 years? I just need you to understand the formula and be able to plug all these numbers into this so you can do the math. I just need you to understand the formula. We're going to look at this and we're going to say, what's it going to be worth in 25 years? Well, the original amount of the painting is $14,000. And so we're going to put a 1 and a plus and then R. It increases by 9%. I'm going to make 9% into a decimal. That's 0.09. And each year, T is years. How many years? Well, 25 years. So I'm going to add 1 plus 0.09, which is going to get me 1.09. And I'm going to put that in my calculator to the 25th power. I'm going to then take that number and multiply it by 14,000 to see how much the painting is going to be worth then. So this is just set up the formula and calculator work. And 1.09 to the 25th power is 8.62. 30806604, whatever, and we're going to multiply that by 14,000 to get $120,723.13. And I copied the problem wrong out of the book. If you're following along in the book, the painting in the book is only worth $1,400, so I'm off by a whole decimal point, but this is the answer for this problem. So try check it out number 1. You're going to get a similar scenario, and you're just going to plug in the numbers and put it through your calculator. Pause here, come back when you're done. For problem number 1, we're finding out how much $1,200 increases by 0.08 at 6 years. This to the 6th power is 1.59, so you're going to end up with $1,904.25. The next thing we're looking at today, because it has a very similar formula, is compound interest. You've done simple interest before, where I put in $1,000 and it sits there for 6 years, and after 6 years I get 6 times the percentage, and that's it. Compound interest is interest paid on principal and the interest earned. So for example, I'm going to put in, say, $6,000 and I get a rate of 6%, but maybe it does it quarterly, which means 4 times a year, and I leave it in there for 7 years. So it gets a little more complicated, which just means that there's more parts to our formula. But again, it's really straightforward. So this formula is the amount that we have is equal to the principal times 1 plus the percentage rate over the number of times each year to the power of the number of times each year and the number of years. So let's get all of these down. A equals the balance, which is the total after so many years. P is the principal, which is the original amount invested. R equals the interest rate, and again, this is usually given in a percent, but you have to write it in a decimal. N is the number of times per year that the interest collects, and it will always tell you monthly or annually or quarterly or something like that. And T is the time, the total number of years that it will be in there. So let's try one. A typical problem. $1,000 is deposited at a 3% interest rate, compounded quarterly for 5 years. How much money are you going to get at the end of those 5 years? Well, our A is going to equal the principal, which was $1,000, times 1 plus the rate, which is 3%, which is 0.03, divided by the number of times a year. Well, it compounds quarterly, which means every quarter, so it's 4 times a year. 4 times a year. To the power of 4 times a year times the number of years, 5. So we have 1,000 times 1 plus, and we're going to put this in our calculator, to the power of 20. This is 0.0075. which is 1,000 times 1.6118 times 1,000. And that gives us $1,161.18. And that's why I went through all of the decimals I did, because you want to take it out to the nearest penny. I have $18,000 that I invested at a rate of 4.5%, compounded annually, which means once a year, for 6 years. So my A equals $18,000 times 1 plus 0.045 divided by 1, and 1 times 6 years. So 1.045 to the 6th power is 1.30226 times 18,000 gives us 23,440 and 68 cents. So pause here, give checkpoint 2 a try, and come back when you're done. Checkpoint 2A, we have 1,200 at a rate of 3.5% quarterly for 4 years, which gives us $1,379.49. And then we have 4,000 at a 3% rate compounded monthly for 8 years, and that gives us $5,083.47. Please make sure you ask if you have any questions. These are the only 2 parts that we're going to cover out of this section. Your homework starts on page 809. You're going to do numbers 10 and 11, numbers 14 through 16. Okay, I'll see you tomorrow.